In this video, we want to show that the derivative of this expression here in the parentheses, 1/2 natural log of absolute square root of x squared plus 4 minus 2 over x, does equal to 1 over x multiplied by the square root of x plus 4. And this is basically an exercise in computing a derivative. In this case, it involves a natural log. Also using some algebra to show that the expression on the left does equal the expression on the right. So you can think of this as proving an identity in trigonometry. You know what the answer is going to be. It's on the right. So use a little bit of common sense and some algebra to confirm the derivative. So I'm going to start over here then on the left side. And first I'm going to do the algebra. So I haven't taken the derivative yet. So this is going to be the derivative. And this is my objective right here. I want to show that when I take the derivative and do some simplification, I'm going to get the expression on the right over here. So what I'll do here is I have the natural log of this expression here. So I'm going to write it this way. Be the natural log of the numerator. Anytime I have a log, in this case natural log of a fraction, I can use property of logs. It tells me that will be the same thing as the log or natural log of the numerator minus the log of the denominator. So I'm going to have this then. It'll be the square root x squared plus 4 minus 2. And then this will be minus natural log of x. So all I did here is took the natural log here of this absolute value expression and broke it down this way. And remember, everything's multiplied by 1/2. So I'm going to have a 1/2 here for this one, and then a 1/2 here. So in the previous video, we had the integral of this. Integral of 1 over x, square root of x squared plus 4. And we got this answer over here. And it was plus the constant of integration. Now I left that off because the derivative of a constant is going to be 0 anyway. So this is basically checking the answer. Okay, now we're going to take the derivative. We'll take the derivative of this expression right here, individually here. So the derivative of natural log of this expression right here is going to equal to whatever's in the absolute value here goes in the denominator. So that's x squared plus 4. And then it's minus 2. And then in the numerator, we're going to have the derivative of what I have here in the absolute values. Obviously, the derivative of a constant negative 2 will be 0. So let's focus on this right here. X squared plus 4, square root of that. Let's take it to the 1/2 power. So it'll be 1/2, and then it's multiplied by the derivative of the x squared plus 4. That's 2x. And then I subtract 1 from the exponent. Remember, this is x squared plus 4 to the 1/2. So subtract 1 from that. That's be a minus 1/2. And this stays x squared plus 4. Okay, so notice this 2 and these 2 are going to cancel. I still have this 1/2 here though. I'm going to put a 1/2 here, and this is minus 1/2. And the derivative of ln of x, again using the appropriate formula here, it's in the absolute values, goes in the denominator, like this. And then in the numerator, take the derivative of x, which is 1. Now what I'm going to do next, now you can think of this as the answer, okay? Because we computed the derivative, so this is really the answer to that derivative. It's not simplified, and remember, we want to show that we get the expression on the right side. The objective is to show that that derivative, once you simplify it, will give us the 1 over x square root of x squared plus 4. So we have to do some algebra. The rest of it is just algebra. So, and this is your objective here. That's the objective. So what I'm going to do here is I'm going to multiply the numerator by the square root of x squared plus 4, and the denominator by the square root of x squared plus 4. Remember, here I'm just multiplying by 1, so that doesn't change the original expression here. So now, the next step here, let's do the denominator first. And remember, think of the square root of x squared plus 4 as x squared plus 4 to the positive 1/2. But let's do the denominator. Square root of x squared plus 4 times the square root of x squared plus 4 gives me x squared plus 4 quantity squared for the radicand, but then that's the square root. So that just comes out to x squared plus 4. And then it's minus, I'm also multiplying the minus 2. So this will be minus 2 times the square root, x squared plus 4. And in the numerator, I still have the 1/2 here, so I'm going to leave the 1/2 right there. These cancel out, I still have the x. And when I multiply x squared plus 4 to the negative 1/2 power 2 by x squared plus 4 to the positive 1/2, the exponent on that is 0. So x squared plus 4 to the 0 power is 1. So that leaves me with 1/2 x in the numerator. And then I got a minus, and then let's just multiply these out. 1/2 times 1 over x will be 1 over 2x. So I look at the objective over here. I notice I want to have an x square root of x squared plus 4. So after I combine these two expressions, that's my objective right here. So I'm going to leave this as 1/2 x. Again, all of this is just algebra here. Now in the denominator, I'm going to factor out the square root of x squared plus 4. So what's that going to give me? So factoring the x squared plus 4 from the denominator leaves me the square root of x squared 4 plus 4 in the parentheses here minus 2. Notice if I multiply these two out, that gives me the square root of x squared plus 4 squared, which would leave me with x squared plus 4. And then the square root of x squared plus 4 times the minus 2 gives me this part. So that checks out. I'm going to pick it up here. So what I'm going to do, I'm going to try to combine these expressions here. So I need the same denominator, the common denominator. So best way to do it here is I'm just going to cross multiply this way. So this will give me greater than or equals here then, and cross multiply this way. 2x times 1/2 x will give me an x squared here. And then cross multiply this way. This will give me a minus. Okay, cross multiply here. So it'll be a minus here. And then I'll go re-multiply this out, and this will come out to x squared plus 4. Square root of x squared plus 4 multiplies the minus 2, so it's be minus 2 square root of x squared plus 4. And for the denominator, it'll just be this denominator multiplied by this one. So I'll have a 2x here, and this will be the square root of x squared plus 4. That's multiplied by the square root of x squared plus 4 minus 2. And then to simplify this right here, we have x squared and we subtract this, so I have a minus x squared there, but that's going to cancel this x squared. So that's going to cancel. I have a minus 4 and a plus 2, so this becomes then 2 times the square root x squared plus 4. Okay, multiplying through by this negative, distributing the negative, x squared minus x squared, and then minus times this will be a plus 2 square root of x squared plus 4, and then this is a minus 4. So that replaces what I just marked out. And now we have this 2 and this 2. So we're going to divide, I'm factoring out a 2 here, so that's a 1 there, and 2 into 4 we have minus 2. So now look what we have left here in the numerator. In the numerator we have left the square root of x squared plus 4 minus 2. But in the denominator we have the square root of x squared plus 4 minus 2. So this right here would cancel this right here. So that's equal to, we had just a 1. Everything canceled out in the numerator, so that's just a 1. In the denominator, this factor canceled out with the 1 in the numerator. The 2 canceled out. What do we have left? We have left x times the square root of x squared plus 4. And that's what we have over here on the right side of the derivative. And that's your check. Some videos that I do, I go ahead and check the answer. Most of the time, it's fairly easy to check. You can see in this case, it'll take you longer to check it than to work it out. So again, this is just an exercise in computing the derivative and using your algebra to get the final result. Thanks for watching. We'll see you next time.